Talking about the phases of composting, those phases are the ones that I've tried to put here. The lag phase is the period of microbial acclimatization. They can acclimatize to the environment. It's often characterized by low temperature. Often your material is still bulky. There's low oxygen consumption at that time. I mean it low oxygen consumption because they are not yet growing fast. And the particles are large. Your tomatoes are still tomatoes. Nothing is turning brown or anything like that right yet. And there's low levels of microbial activity. Then we go to the next phase, which is the active phase. That's when the temperature starts to go up. It is a period of intense microbial growth and microbial activity. In fact, if you look at the way microorganisms grow, bacteria especially, you can superimpose that on the phases of composting, almost identical. Where you have a log phase, a large phase, a stationary phase, a population decline phase. Temperature in the thermophilic phase, will be at least, when you get to that phase, exceed 50 degrees Celsius or 140 degrees Fahrenheit. About that. Now, please, the idea of thermophilic, thermo just means hot. Philia, it means to like. Thermophilic will mean when the bacteria that likes hot temperature, that's where they live, where they love. Low temperature bacteria, we say they are psychrophilic, not psycho, psychrophilic. Whereas those that like to live at the body temperature, like us, we say they are mesophilic. So even when they're talking about mesophiles, warm temperature level, thermophile, hot temperature level, psychrophiles, low temperature level. What we are saying is that at this phase, the temperature is moving from mesophilic temperature to thermophilic temperature, from room temperature to hot temperature. Often, if you have a lot of nitrogen in the system, this is the point where there's going to be a lot of release of nitrogen in the form of ammonia. And that is an indication. Immediately you see ammonia being released in the first few days of your composting process, you know that there is something wrong in terms of the balance of the nitrogen and the carbon. The active phase is also a period when you start to see drastic reduction in volume. You see characteristics in the thing is now you cannot see green stuff now becomes brown stuff. They started to turn brown. And they will actually stay brown. What is happening is that some of the short chain hydrocarbons are now being broken down. I mean, long chain hydrocarbons, they are now being broken down into shorter chains. And organic waste is now, with time, it gets darker. It's becoming there's more humus or humic acids being produced from it. And that takes us to and you remember that active phase, I said that to maintain the high rate of composting, you need to check often to be sure that if your temperature is going down, you turn it, you add moisture to it if it is necessary. If it is the bulk, you need to fluff it up. If it is bulky to the point that air cannot get into it. And it will stay in this temperature for as long as the condition is right. If it gets to the point where you do everything that needed to be done, and the temperature don't stay up anymore, it starts going down, it means it has finished. Now, I always like to give a point of caution at this point. Many people will ask me, I've been composting my park for the last 6 months, and it's not ready. When will it be ready? And I ask them, how do you manage your compost? Oh yeah, I just add to it every day. I add my more to it every day. If you keep on adding to your compost every day, it will never be ready. Because you are trying to keep it at the active phase. You continue to provide nutrients to them. And that's what people don't really understand. They think, keep on adding to it, one day it will be ready. It will never be ready. You are giving them more nutrients. So, if you really want your compost to be ready, once it gets to a point, keep it on the side and start another one. Does that make sense? If not, it will never be ready, and when you use it, it will be toxic. Because you kept the bacteria in the active phase. Okay? So, over time, if you then enter the decline phase that we have talked about, temperature falls and it stays within 10 degrees of your ambient temperature, it's still using oxygen, but very low, and available nutrients have been exhausted. The bacteria are just trying to hold on. And now, at that stage, you now see some of the insects coming back. Some of the mesophilic bacteria are now coming back because the temperature has cooled down. Hot temperature will kill mesophilic bacteria, but now since it's cooling down, they are coming back in there. There may be it may be slightly low, the pH of it will be a little bit low because of the humic acid and others, and some of the organic acids in the system. And that brings us to the curing phase. I mentioned that the curing phase is possibly the most important phase of composting. The compost is still immature. It's still using a little bit of oxygen, but it's slow down so much. If it has very high carbon to nitrogen ratio, which is possible, depending on what you are starting with, because from this time on, your carbon to nitrogen ratio will also try to go down, because it's still respiring, but it's not using carbon and nitrogen much anymore, but it's using some of the carbon. So your carbon to nitrogen ratio starts to go down. You now have more humic acids being produced, or humus. Let me just say humus being produced. And during this phase, it starts to mature. Maturity, therefore, is a point. It matures at a point. And people ask me then, when is my compost ready? When does it get to maturity? Maturity of compost, or the use, will depend on what you want to use the compost for. I just want to explain this. If it is just to do some reclamation work, or just want to add nitrogen organic matter to the soil, you are not really or interested in using it to grow certain type of plants, some hardy plants, halfway through the curing phase. It may actually work for you. But usually we want it the phytotoxicity to be gone. When your compost is created ready, the pH now starts shifting to neutral, close to neutral. Usually between 6.5 and 7. And your carbon to nitrogen ratio gets lower, usually below 25. You start at between 25 and 40. That appears now because the volume is reducing, but you now have the same amount of nitrogen. The concentration of nitrogen tends to increase in it, in fact. Your proportion of humus increases. A lot of your nitrogen now is in the nitrate form. No man, you can't find ammonia anymore. If you find ammonia at this stage, your compost will stink. It's not a good compost. In addition, many of the microorganisms that were in the soil before, you now find them now in your compost. All this other time, your compost is almost sterile of normal microorganisms you find in the soil. They now start coming back, including the actinomycetes. All these ones that I call phenolics and some of the fatty acids, they are what make the compost toxic. Now there will be a drastic reduction to the point that they will actually, the actinomycetes would have converted them into humus. I was talking about phytotoxicity. Let me show you a couple of pictures, and it's going to. Okay, let me show this. This is compost that we tried. No compost, 5%, 10%. This is compost. No compost, 5%, 10%, 20%. Identical. If I tell you it's the same compost, you believe it?
No.
It is the same compost. Yes, for both. But this one was taken at the end of the curing before the curing phase. This sample that we use here. It's an immature compost. If you do like a small experiment for yourself, you take your compost, and the more you add to it, the less that plant grows. That material is phytotoxic. In this particular case, if you go beyond 5%, nothing grows. It kills the plant, even grasses. Because this was taken towards the end of the temperature decline phase. when this same compost that is immature was allowed to fully mature, the same compost, we didn't add any nitrogen or anything different. You see the difference? And then another thing you get from this is the fact that, and this is important when you are talking about compost use, you don't use the compost alone. It's not soil. The recommendation is really you should not even use more than a quarter of whatever you are using. Compost should not be more than a quarter. I prefer using just about 5 to 10%. For some people, I want to put as much compost. You are just wasting your compost. Look at the difference here. 5%, 10%, 20%. You don't actually get much return once you pass the 5 to 10%. Does that make sense?
Yeah.
So don't waste your compost. Instead of using it on an acre, and you are using it on a quarter of an acre because you put too much. Okay? How can you test that your material is ready? Because it's not that you will be able to set up everything like an experiment like that. Okay? For your compost to be ready, there are two plants or two types of seeds you can test on your compost sample. They are watercress or radish. We try to use these two for 3 reasons. They germinate very fast. Have you ever planted radish? You put it in this morning, by tomorrow night it's already purple. Is it not true? The same thing with watercress. So is that they grow very fast. In a week, it will have been this. 3 weeks later, you pull out radish. Is it not?
Yeah.
These two are very easy. The reason is, if you have to test whether your compost is ready or not, and you put it like tomato seeds in there, it takes 18 days to grow, to germinate. And before you see any noticeable growth, it takes another 2 or 3 weeks. By that time, things have changed in your compost. So we use those two. They are the two that are recommended: watercress or radish. And if you are going to do it easy, you can use plastic cups or regular cups, or you can cut one of these into 2 and fill it up with compost. Turn this one upside down, fill it up with compost, and put 50 seeds. You know, these things grow very small. 50 seeds of watercress or 50 seeds of radish. Water it. Keep it on, just let it grow. Check it 5 or 6 days later. 2 things you have to check: how many seeds grow, and how quickly do they grow. The germination and the growth. Okay? If your compost has got to the point where it's mature, you will get at least 90% growth when you compare with regular soil. So, if I'm doing compost, I'm going to do my soil, that the one that is not contaminated, as a control. If, for example, 10 grow in my control, and in my compost, 8 grows, that's only 80%. I will say that compost is still phytotoxic. But there are some times your compost will actually, if you let it mature well, seeds that will not grow normally in soil will grow in it. I have an example and I will show you that. So in that case, it will be more than 100%. We expect it to be at least 90% germination when you compare it to the control. Does that make sense?
Yeah.
And not just all, and at least 50% of the biomass. The only reason why we do that is that, you remember I said compost itself is not a soil for growing things. It's a fertilizer. Don't add it more than 25%. If it's more than 25%, it may reduce the rate of growth, not the rate at which it grows, not the rate of germination. But because we are using compost alone, the rule is that your biomass or the height of the plant must be at least half of what you find in your normal soil or what you are using as your control. So do the two combined, not one, both. So even if it grows very well but didn't allow the seeds to germinate, then it's still phytotoxic, or both. Either way. So let me show you an example. This was a real life example. I did this for a project that they were doing in Haiti. I used to work in Haiti as a representative there. And we had a project on use of organic matter in the soil that we did across the Caribbean. So the Ministry of Agriculture there, they use some type of manure that they said has been composted for one project. So I went to visit and to look at the field. And every time, a particular field of the project, a particular plot, you get there, nothing grows. And I said, what happens? They said, well, we think that the material we added had a lot of heavy metals in that. How did you know? We just think so, because nothing grows. I said, it may not be heavy metals. Do you have an example of the compost that you use in that place? They said, yes, we do. The old compost that they use. In fact, what we did was we went to where they said they collect the compost, collect fresh ones. And that fresh one is the one that I use here. Then I asked, do you have the old compost that you use? They said, yes. We piled it at the back. We took it here. You understand what I mean? It's the one that I use here. And then we use the soil that they have on the farm. This is what we got. Fresh compost, nothing grows. And it's the same compost that it has aged now about 2 months. Something grows. Everything grows. It grows better even than the soil. So this compost is matured. This is not mature. You compare it to this. Does that make sense? So if you have your compost and it has finished the process, just take a cup of it or 2 cups, put those seeds in there, do another one. And if you leave them long enough, you may still actually be able to harvest some radish in there. I'm telling you, radish is crazy. Just come out there. Okay? So, for example, in that one, from before, we harvested them. Compost, aged compost. The one that is nothing grows there, compared with the one, the regular soil. So, in this case, when I looked at it, based on what works we talk about, 71 growth, 71% here, but compared to the control, compared to 80%. When we compare this to the control, it is 124% of the control. It grows more than the control. And this is 0. So in terms of germination, this is okay. This is not okay. In terms of the rate of growth, I decided to just use the biomass, the total biomass here. In the control, 14 grams. In our compost, 15 grams. The compost is better. So in both cases, it means if 90% germination and a minimum of 50% growth. So this compost, that aged compost that I show you the picture, is therefore mature. If you are going to sell that compost, nobody will use it and say, my plants didn't grow. It means their seeds are not good. The reason why we compare to control, and not just with the number of seeds you just put in there, is that sometimes you buy seeds, the seeds itself has lost some germinability. And therefore, that's the reason why we compare it to another one where we expect it to grow. If it doesn't grow in the other one, it means there was a problem. And then we call that one the control. Okay? Any question on that, please? Okay. 5:34. I have 26 more minutes. So, what are the optimum conditions, therefore, for composting? If you want to compost, what should you aspire? What conditions should you aspire to have? So, I will just summarize it on one slide, and then we'll quickly go through it. Everything we'll be saying today, a lot of the things, you'll find it here. One, I will talk about what is down here first, before I talk about what is here, because a lot of things here will result in what you have here. The first one is the carbon to nitrogen ratio. The amount of carbon to the amount of nitrogen. More or less, is giving us an idea of the amount of energy source to the amount of protein source that you have in there, or nitrogen sources that you have in there. The total amount of carbon compared to total amount of nitrogen should be in the range of 25 to 1 to 30, 40 to 1. That doesn't mean that you take 25 types of wood chips and add it to one type of part of grain material. That's not what it's saying. Because both of them have a lot of carbon in them. So you are increasing the carbon at the same time. But the total amount of nitrogen. This is where, when I was talking about the art of composting, some people will know, or I've been doing this for a long time, I'll just take 2 of these, add 1 of these to it. If it works, you'll find out that it falls within this range. If your compound material is smelling of ammonia, the number falls below this range. If it wouldn't heat up and everything is right, and you have very long lag phase that I talked about earlier on, it's likely to fall outside of here. If therefore you are mixing manure, let's say tomorrow, and you decide to use wood chips as a source of carbon, when you mix the manure and wood chips, we just want the carbon to nitrogen ratio in them to be in that range. If it wouldn't heat up, we may need to add more manure, which is the source of nitrogen. Generally, your source of carbon, we call them brown materials, like wood chips, but it also includes everything like sugar. It's also part of it. Or paper, coffee ground, all those things. And even leaves that are brown, brown leaves that have been shed are part of brown stuff. Green materials, they include green leaves, green grass, meat products. I know people are looking at me, why are you telling me? So they've told me I can never compost meat. You can. Meat products, even nitrogen fertilizers are part of things you can use as a source of nitrogen. Quickly, I mentioned when I was talking about that you can put meat, milk, and everything in composting. The reason why they don't put it, especially when you are having a backyard compost. You remember people just put a little bit of this and they leave it. A little bit of that and they leave it. It doesn't have the bulk in most cases. In most cases, it doesn't heat up to the 55 degrees Celsius or 140 degrees Celsius. When was the last time you actually put your hand in a backyard compost and it reached that temperature? So the reasons why we always say don't put it in backyard compost is because people don't know how to manage it for the temperature to reach that so that it can kill all the pathogens in the meat, okay, or the manure, or you can put pet droppings and all those things in your backyard compost, or milk, because if you put them, or fat, and you don't mix them well, you don't have the bulk, you don't reach the temperature, you have insects, you have rats, you have mice, you have everything coming in there. Whereas, if it's a big pot, and you put everything in there, and 5 minutes, 10 minutes, 2 hours later, it's already hot. Nothing even comes close to it. And it reaches that temperature, it kills them all. So I'm just saying, the reason why they always tell you, don't put it in your backyard compost, it's not that you cannot compost it. It's because, in most cases, the temperature is not hot enough to kill them. Okay. The oxygen must always be greater than 10%. Normal oxygen in the air is about 21%. In the air that we breathe in, about 20.9 or 21%. Okay? What we are saying is, if your compost pile gets below 10%, the bacteria they start to suffocate. And that's when they produce more acids rather than producing carbon dioxide. Okay? And that's the reason why you have to turn it. Normally, at 10% is not yet anaerobic. At 10% we use the word, it is anoxic. The lack of oxygen is making it toxic for you. When it becomes anaerobic, what that does is that bacteria that we want in compost, the aerobic bacteria, will not grow in it because now it doesn't have oxygen. You now have the bad guys growing and they create odor, hydrogen sulfide gas, the one that smells like rotten egg. So we try to keep the temperature, we try to keep the oxygen above it. The other one is the pH. If you are using regular material, don't worry yourself about the pH. pH will fall within this for regular material. The only situation where the pH may be lower will be if you are using certain industrial type of waste that has been processed, and because of the chemicals they use in the process, that the pH has gone down. For example, if you are using waste coming from a fruit processing plant, okay, many of those will be acidic. You may actually have to lime it or mix it with other things for the pH to go back up. Okay? We want the temperature to get to 55 to 65 degrees Celsius or above 140 degrees Fahrenheit. Now, this will occur always if the bulk is good enough. Sometimes, if you can maximize the backyard compost or small compost and everything is close as possible, the core of it will be hot enough. But if it's a smaller pile, you may not get that temperature. That's what I was saying. In those situations, you may not be able to add some things to it. If we are just doing a trial like what we are going to do tomorrow, and it's just going to be a small pile, I doubt whether we'll be able to get to this temperature. But we may be 5 degrees, 20 degrees, 30 degrees Celsius more than the control. But you see the difference. It's going to heat up. Moisture is the amount of water in there. The best range is from 50 to 60. It will still be working, but slow, between 40 and 50. But once it gets below 40, composting will stop because there's not enough water. Once it gets above 65, that is when you go there and you look at your pile and you see water oozing out. You see leachate. And when leachate comes out, it stinks also. Smell. You see a lot of smell. We don't want it to get to that point. All these parameters, you can measure them. You can use the thermometer, and we are going to do that to measure the temperature. You can use your hand. You can even to see whether it's anaerobic and ammonia is being produced. You can use your nose to smell it. I always tell people, for the moisture content, the normal thing that is done in many places is to take sample to the lab, they dry it until it is totally dry and dry it again, and then you calculate the amount of water that is dripping off. But that may take 4 or 5 days. It's too late. If it's already too dry, you need to add water. So the easiest way, I always tell people, you squeeze it, the squeeze test. Your composting material that you are composting, when you take it, please listen to this, and squeeze it as hard as possible. Water will barely be coming out. If it is you squeeze it, water is coming out, the moisture content is about 65%. And if you squeeze it, water is not coming out, and you throw it down, and there's no water in your hand, it's too dry. Your moisture content will be way below 50. Does that make sense? Yeah. So if you just squeeze, if water is coming out, find more dry matter to put in it for it to work. It may be wood chips, it may be dry leaves, it may be whatever. If it is too dry, put more water in it. That may be all what it takes and what it needs. Does that make sense? Yeah. So these are critical. Particle size. Like the other day, in 2 places, we have different times, we had different types of material. We had some waste from some of the stem from the palm, and it's degrading. And then one of these guys came and just used the knife, the cutlass to chop it into small pieces, because we don't want pieces bigger than this. If you put something that's like this in the compost pile, it's not going to break down, like wood, for example. That's what we mean by particle size. Bulk density is how compressed it is. Sometimes, when you are composting, over some time, the compost pile settles and becomes dense. That's when the bulk density increases. Usually material people compost tend to fall within this, which is about 1,000 or between 900 to 800, between 800 and 1,000 pounds per yard, the weight of the material. Okay? Any questions on that? Let me because tomorrow we can do other things in the field. I can explain other things in the field. Let me quickly show you the one that I was talking about, that I mean that or maybe I need to cut it and put it in there. Oh, this is what happens when okay. Where do I change it? The screen is not coming. It's not showing. Let me wait a minute. Just give me a second.
I did the market.
No. Okay, try it. It's still not show. Okay, try it. Yeah, just. This is what I'll do. Okay, go ahead.
99, somewhere around that.
Just don't worry. If it doesn't, I'll make it work. And if it doesn't work, that's okay. I'll just turn this. I will turn it the other way. It won't come. Control panel. This is what I will do. I will have to go to control panel, to settings, and then it's going to work. Just a second, please. I'll make sure that at least if this doesn't work, then we have to find something to. You did that the other day also. Okay, this it doesn't work. If I can't make it work, I will. I don't know. I remember I did that the other day, and I don't want to use my other one. Okay, if this doesn't work, this is what I will do. I don't want us to waste time, but I will make it. I just do it right here. What we do? Okay, I've just done this. Okay, please. If you move your chair here, you'll see what I'm saying. Please, just for a minute. Let me see. I don't know why it's not showing there, but yeah. See, this computer is in Spanish most times. So okay. Yeah, I think it is here. Okay, I think I may be able to fix it now. It should work. If it doesn't work, then that's too bad. But anyway, you see, it wouldn't work. Okay, let me just go back here. What? No, I told it to duplicate it and everything. What I will show it to everybody. I will move it around. Okay. What we do here is this. This particular software has a list. Okay. I will go for. Let me start from here. I will show them here now. We have a list of different feedstock, whether wood chips, manure, mentioning industrial waste, municipal waste. That if you go there, it gives you information about each type of material you have. You see the list. The carbon to nitrogen ratio, the amount of nitrogen, the amount of carbon, the amount of moisture that they normally contain. Okay? Same thing here. You can go to the list, which is one of the spreadsheets. And what we've done is, we've created a software that you can go and speak on any of those lists. Say, I'm having this number 1, number 2, number 3. In this case, I have here food waste. I have wood waste. I have here other amendments. And I have water. You can add anything to it. All those are in the list. All you need to do here is, once you have picked what you want to be here, you go to this column where that is yellow. If, for example, I say I have, let me go back up because it's not all the way up here. I will come and show it to you. I have poultry manure, food waste, wood waste, and I can add the other two, but we pick 3. Poultry manure, food waste, and normally when you go on it, this will be, you can change it to 0, 0, 0. Nothing there. This column. Only where there's yellow. Nothing here, 0. Nothing here. Okay. I change it. The amount, I have 0 poultry manure, 0 food waste, and 0 wood waste. Assuming that those are the 3 that you have. Let's say I said I want to proportion to mix it. If I'm mixing it, one of each, for example, I have one of this, each of them. One of food waste, of wood waste. Sorry. One of food waste, and one of poultry manure. Now, this is telling me that the carbon by weight, if I'm mixing it by weight, my carbon to nitrogen ratio is too low, 20. But my moisture is good. Does that make sense? If I'm mixing it by volume, which most farmers mix it, 1 volume of this, or 1 bucket of this, plus 1 bucket of this, plus 1 bucket of this, it shows that my carbon to nitrogen ratio is too low. Which means anything that is of carbon here, I need to put more of it. Does that make sense? Like wood waste. If I increase the wood waste here to 2, you'll see how this will change. If I'm mixing by weight, it is 31 to 31, which is perfect. But it's too dry. This is what I'm saying here. I put 1, 1, 1. It shows that red, that my carbon to nitrogen ratio was too much. Too low, too much nitrogen. So we increase it to 2 for wood waste, because that contains more carbon, it's more brown. And if you do that, it is okay. If you are mixing by weight, since let's say you are mixing by volume, it's still too much nitrogen. It says 21. You understand what I mean by mixing by volume? Most people on the farm, in the homes, they mix by volume. 1 bucket. Nobody finds a scale to weigh 20 kilograms of this or 40 kilograms of that. So if you are mixing by just volume, you look at the second column. It still shows that it's too much nitrogen. So if I increase that one, let's increase it to 3, and you see what it's going to show me. if you are mixing by volume, 3 of the wood chips plus 1 of the food waste and 1 of the poultry manure will give you a carbon to nitrogen ratio of 27. I think one of those things.
No, I turned
Oh, that one, okay. We give you a carbon to nitrogen ratio of 27, but the moisture now is 49, just below 50, which will work. But you can add water to it if you want. So I can go back here and say, okay, what if I add water? 0.5. 0.5. See what it shows you? Carbon to nitrogen ratio is 27, perfect. Moisture content 60. So if those are the 3 things you are using, it means 1 part of chicken manure, 1 part food waste, and 3 parts of the wood chips will compost well by volume. When you are dealing with material that has a lot of carbon, if you are going to add easily available nitrogen to it, make sure that you add it in parts, like put a quarter of it first. And then when the smell and everything is gone, put another quarter. The only other way you can do with that situation is, in that big part, if you have other type of waste with a lot of sugar in it, if you add it to it, it's going to kick off and the odor will go away. Because you have now balanced available carbon with available nitrogen. For example, that part is stinky and you realize the available carbon is not much, but you get some molasses waste or something and you mix it with it. Some people will tell you when they are doing composting, they add some molasses or they add something and it works. That is really what is happening. They are making the carbon available. Like the one that I talked about, the wood chips, it was a place where they process wood. So I told them, they said, well, they can't be there, balance everything. I said, okay, let's do an experiment. Put a big part here, put another big part, and get me 20 kilograms of sugar, the bag of sugar. Mix it with this one. They did it. By the following day, that one is steaming. It's just because they've added too much nitrogen for the available carbon that you have in the part. So we'll continue tomorrow, 6:01.